There is a fully functional AI model running right now inside a browser tab. No server. No API key. No internet connection required after the first load. You close the tab, it's gone. You open it again, it runs again. Entirely local. Entirely inside the browser. This is Gemma Gem. And the fact that it works at all is genuinely surprising, because browsers were never designed for this. Let's talk about what it actually does first, because the demo is the most convincing argument. Gemma Gem is a web component, one HTML tag, that you drop into any web page. When the page loads, it downloads a quantized version of Google's Gemma model directly into the browser. Not to a server. Not to a backend. Into the browser's own memory, using WebGPU or WebAssembly for inference. Once that model is loaded, you have a working AI chat interface. Ask it questions, give it instructions, it responds. All of that processing happens on the user's machine, inside the browser process itself. The setup is almost offensively simple. You add a script tag, you drop in a custom HTML element, and that's it. There's no Node.js backend to configure, no Docker container, no API quota to worry about, no billing dashboard. A developer who's never touched AI infrastructure can have this running in under 10 minutes. And here's what surprised me most in testing: latency. Because there's no round trip to a server, responses start appearing faster than you'd expect. The bottleneck is your GPU, not a network call. On a machine with decent WebGPU support, token generation is genuinely usable. But here's the thing, and this is where it gets interesting: the model that fits inside a browser is not GPT-4. It's not even close. Gemma Gem uses a small, heavily quantized Gemma model. That's the honest constraint. Small models are good at conversation, summarization, basic Q&A. They are not good at complex multi-step reasoning, precise code generation, or anything that requires deep world knowledge. If you ask it to debug a subtle concurrency bug or explain a niche tax regulation, it will produce confident-sounding text that may be wrong. That's not a criticism of this project specifically, it's a fundamental property of small quantized models. There's also the loading time. The first time a user visits a page with Gemma Gem embedded, the model has to download. Depending on the quantization level and the user's connection, that can be anywhere from a few seconds to over a minute. That's a real user experience problem for public-facing apps. You can cache it after the first load, but that first visit is a hurdle. And privacy, which is actually the selling point here, is also a constraint in disguise. Because the model never sends data to a server, you also can't log conversations, improve the model over time, or do any server-side analytics. For some use cases that's perfect. For others, it's a limitation you need to plan around. Browser compatibility is still uneven. WebGPU is not universally supported. On browsers without it, Gemma Gem falls back to WebAssembly, which works but is significantly slower. Safari support in particular is still catching up. If your users are on older hardware or non-Chromium browsers, performance degrades in ways that are hard to predict. Now, where could this realistically go? The most compelling near-term use case is privacy-sensitive tools. Think medical intake forms that summarize patient input before a doctor reviews it, legal document pre-screening, mental health apps where users absolutely cannot have their words sent to a third-party server. Right now, those use cases either avoid AI entirely or require expensive on-premise infrastructure. A browser-embedded model changes that calculus. You get AI capability without the data liability. There's also an offline angle. Progressive web apps that work without internet connectivity are already a thing. Adding a local AI layer to an offline PWA is now technically possible. Imagine a field inspection app that runs on a tablet with no signal, still capable of generating structured reports from voice notes. As WebGPU matures and model compression techniques improve, the quality gap between browser local models and cloud models will narrow. Not close completely, physics still applies, but narrow enough that many practical tasks become viable. So why does this project exist? Because the default assumption in AI tooling is that you need a cloud. Every major AI product is built around that assumption. API keys, rate limits, billing, latency, privacy policies, data retention clauses. All of that exists because someone decided the model lives on a server. Gemma Gem challenges that assumption. Not by being better than cloud AI, it isn't, on raw capability. But by being useful in contexts where cloud AI is either too expensive, too risky from a privacy standpoint, or simply unavailable. The developer behind this is essentially asking, what if the model was just part of the web page? Like a font or a JavaScript library. Something that loads, runs, and never phones home. That question is worth taking seriously. Because the answer, it turns out, is, it works. Not perfectly. Not for every use case. But it works. If you've been thinking about embedding AI into a project but you've been blocked by API costs or data privacy concerns, this is worth an afternoon of your time. The GitHub link is in the description. Next episode, we're looking at another project that runs entirely on local hardware, this time for document parsing. If that's relevant to what you're building, subscribe so you don't miss it.